Hi, everybody. So, in this video, I'm going to be talking about some things that I think are pretty interesting. I'm going to be talking about Raspberry Pi. I'm going to be talking about OpenPlotter, rtl-sdr, which gives you AIS, and something called a motissier hat. And for a lot of you guys, this probably sounds like gobbledygook. But the takeaway is that this is a very inexpensive way to set up a chart plotter and a chart plotter that receives AIS, right? A bunch of other stuff on top of that, but that's sort of the main kind of goal that we're going to look at with this. So this came about because of some conversations that I was having with Rebecca Childress, and through her Patrick as well. And if you're not familiar with them, they're very accomplished sailors who are currently sailing around the world, and their beautiful sailboat called Brick House, right, which is a great name for a boat. And they did a tour of their navigation systems. On that tour on their YouTube channel, I commented about something called OpenPlotter, and to my surprise, they weren't familiar with it. And I think that I may have assumed that this was just kind of common knowledge because A, I live in California, so there's a lot of tech stuff around me. B, I come from a tech background, so it's something that I'm already kind of very aware of. So when I started looking at getting a boat, I just sort of naturally gravitated towards looking at Raspberry Pi and seeing if there was some navigation stuff for it. And I think it's really, really useful. So I'll give you just sort of the 10-second kind of summary of the whole thing, executive summary kind of deal. So with a couple pieces of hardware and software and not too much effort and very little technical know-how, right? You'll need to know a little bit, and this might seem intimidating initially, but it's not very difficult. It's just a couple steps that you need to go know. And hopefully I'll lay it out in a way that'll make it sort of understandable for you. You can set up a system to receive AIS on your boat. You can go ahead and have this run OpenCPN and a number of other utilities that I think can dramatically increase safety at sea because of the navigation capabilities and AIS. And you can use this in one of two potential ways, right? So if you're somebody who already has a chart plotter and GPS and navigation and all that kind of stuff on your boat, you could go ahead and take one of these little Raspberry Pi computers because they're so small, and you could go take that and you could go put it in your stove Faraday cage, right? And if you got hit with lightning or anything kind of happened that took out your primary navigation equipment, you could go use this as a backup. So that's the first scenario. The second scenario is you are somebody who is not in a position to be able to afford expensive navigation equipment to go put an AIS receiver on your boat. You have older marine equipment. Maybe you've got an older radar. Maybe it's a NEMA 0183 system, something like that. You can take one of these little Raspberry Pi devices and you can use that to really get most of the functionality that you would get with a much more expensive system. There's also some stuff that I'm going to talk about at the end of this, which I think is particularly nice, especially related to the marine device communication aspect of this. But that's really sort of secondary. The primary things I think that are the takeaway is for about or less than $150, you can have a very nice system that allows you to go do chart plotting, that allows you to go ahead and have AIS, and be able to potentially extend that further to take advantage of a lot of different things on top of that. So that's the first piece. On top of this video, which is going to sort of function as an overview, I'll record some additional videos that kind of get into the specifics of each one of these components. So this is just sort of your overview. You can sort of decide if this is something that you want to go look into. And then what I'll do is I'm going to set up a new channel for this because in the discussions with Patrick and Rebecca, it seemed like something that would be really nice to get out there so people could be aware of it. And I put a video up for them, but I put it on my personal channel. And I don't want people sort of going over there because there's no, just videos of my dog and stuff like that. So I'm gonna go set up a channel, and then what I'll do is on that channel, I'll upload some additional videos that go over how to go install OpenPlotter on the Raspberry Pi, and then we'll go over each of the sort of additional pieces, and then maybe I'll sort of go down to my boat and take some video of the system in action, showing AIS targets and things like that. So this is going to be an overview. It's not going to have those other ones, but if you go to the same channel, and I think Patrick and Rebecca are going to sort of take this video and sort of use it on their channel, which is completely fine with me. I'm giving them 100% permission to do that. This will be Creative Commons. If anybody wants to go ahead and take this content and reuse it, cut it up, whatever you want to go do with it, that's completely fine. I'm basically making this video because I think it's useful for people, and I think that AIS is incredibly important, and it's something that could increase people's safety. So if by spending half an hour, 45 minutes talking about this, that could potentially save someone's life or something like that, that's massive trade-off. Yeah, so do whatever you want with this content. This is not a money thing. I'm fine. So anyway, getting on to the conversation, right? So we're going to be talking about a number of different things in this sort of overview, and there's going to be a couple different pieces to it. Go back over here. I started this before, but I got interrupted by one of my students who was taking an online class with me. So there's a couple different pieces that are going to go into this, and the first piece is the Raspberry Pi, right? There you go. That's weird. Okay, let's go back down over here. Make it a much bigger font size. The Raspberry Pi, right? So that's the first part. So the Raspberry Pi is a computer. It's a very low power computer. It was designed to teach little kids programming, and despite the fact that you probably have never heard of these, this is the third most popular computer in the world. So there's lots of these. Raspberry Pi as a platform is very, very, very well proven. It's used in a lot of applications, among which are in sort of industrial stuff. So the great thing about a Raspberry Pi is they're very small. They're the size of a deck of playing cards, basically. So this is in a case that will come to you with just the motherboard. You can optionally buy a case for it. For marine stuff, probably what I would do is I would actually stick this in some Tupperware, right? So I would just take the board itself, I'd stick it in some Tupperware, put the lid on it, and that way it's not going to get salt, air, and get corrosion and stuff like that. And then maybe what you do is you just cut a little hole in the Tupperware, put the cables in, a little bit of hot glue around them or something like that, and you get a nice little airtight seal, and that should probably be pretty good for most people. So Raspberry Pi, we'll look at that shortly, but this is a tiny little computer, right? This computer is going to go run Linux, and that might be a little bit intimidating. Don't worry about it. Nothing that we're going to be talking about here is going to require you to get on the command line or do anything advanced. You're just going to have a little desktop, you click around, you launch open CPN, and then basically that's where you're going to live for most of this. There's going to be a couple other applications and stuff that you need to go configure, but it's very, very straightforward. You don't need to have any real technical abilities above and beyond just basic desktop computer usage to go set this up. So the Raspberry Pi is great because it runs on USB, right? So it basically has a little micro USB. They actually just came out with a brand new one of these, the Raspberry Pi 4 today. So I think that one uses USB-C, and it might be a little bit higher power. But for us, probably the Raspberry Pi 3 is the way to go. It's not very powerful. You're not going to be playing video games on this or doing anything like that. But it's got about 1 gig of RAM, and it's got, I think, 4 processor cores. So similar to kind of like a little bit of an older cell phone in terms of power. But the great thing about that is the amount of power that it consumes is negligible. So at max, it takes about 2 amps at 5 volts. So if we're looking at a 12-volt system, basically we can go convert that over to 10 volts really easily. So basically that's 1 amp, right? So if you basically if it's 5 volts, 2 amps, it's going to be 10 volts, 1 amp, right? And then because we're 12 volts, it's going to be a little bit less than that. So we're probably looking at like 0.8 amps at max, 0.85, something like around that range. So very, very low power draw, and that's at maximum, right? So that's when this thing is really, really, really chugging along, trying to do a whole bunch of processing stuff, and we're not going to be doing that very often. So we're probably looking at maybe, half an amp, something like that. So for a chart plotting, right, computer. So that's really, really great. It does a bunch of other stuff that we're going to talk about as we kind of go through this. But the core functionality that I want to talk about is the chart plotting and the AIS piece, because I think that's going to be the highest value. So we get the Raspberry Pi, and the idea is that there's a whole bunch of things that people would traditionally plug into this that'd be really useful. So they have a GPS, right? So they plug it into that via USB, and then they would have maybe something called an rtl-sdr, which is real-time Linux software-defined radio. And this allows you to go ahead and get AIS and VHF and HF, which is like ham, radio stuff. Right. So basically what happened is the Raspberry Pi being so cheap, being so easy to use, and the fact that OpenCPN was around made this a really nice little chart plotter. So if you want the absolute most basic kind of version of what I'm going to talk about, you could just go on Amazon, you could buy a little hockey puck USB GPS, and you could go plug it into a Raspberry Pi. You could also get an rtl-sdr, and you can go ahead and plug it into your Raspberry Pi. Now, if you don't want to go use a Raspberry Pi, you could just substitute that piece with your Windows computer or your Mac, and just go plug those in there. And that's a decent sort of basic chart plotter, right? But this is incredibly low power. So that's sort of the base of this kind of setting up. So we'll talk about the rtl-sdr stuff a little bit more in this video. But this was a great kind of idea. So what we do, this is sort of the hardware side. And then on the software side, right, we had OpenCPN. Right. So we go ahead and install OpenCPN on Raspberry Pi. And there's a bunch of other programs that are out there that are also very useful for, a chart plotter or like a navigation computer, that kind of thing. Some of them are for like WeatherFact stuff. Right. So there'll be WeatherFact software that you could go ahead and install on here. And then we could go ahead and install things like something called Signal K, which allows you to go ahead and have a whole bunch of devices send like NEMA information to a central hub. This basically functions like a multiplexer. And that might be sort of a term that some people are not familiar with, but I'm guessing for a lot of you guys as sailors, that's something you're familiar with already. So a multiplexer is a device that takes signals or information from a bunch of devices and presented it as one thing, right? So you see this a lot when you have NEMA. So you can go ahead and have this come in from NEMA 2000 or NEMA 0183. Is it NMEA? I always forget. I'm saying NEMA, that sounds better in my mind, but this might be NMEA. One of the two anyway. But the idea is you can go send all those devices in here and then we can get that information in one place. We'll talk about this more later on. So there's a bunch of different things that sort of naturally kind of fit with Raspberry Pi. So this is really low power, right? And then we have software that's really useful, and then we have hardware that's really, really useful. So this group came about called OpenPlotter, right? Right. So it's basically just a project. It's completely free. It's open source. And what they did is they said, let's take a collection of all of these utilities, and we're just going to go create a version of Linux that you can go download. You can put on an SD card, and you can plug that into your Raspberry Pi, and then boom, you have everything ready to go. Right. So they did that with the software side, and they give this all away for free. Right. So there's no cost with OpenPlotter. It's basically just a pre-configured OpenCPN setup with a bunch of additional utilities that are already pre-installed. So the next thing is that there's a bunch of utilities like the hardware that we're talking about with the GPS, with the rtl-sdr, but other things as well. So like a barometric sensor, magnetic sensor, a tilt sensor, like accelerometer, things like that, gyroscope, basically. So there are all these kind of different hardware things. And they said, well, let's go create a device, right? So the software is for free, but we're going to go create a device called the motissier hat. That basically does all of this stuff, right? So you can just get one thing. And the idea is that you could go ahead and take your Raspberry Pi. So you get your Raspberry Pi, you install OpenPlotter on it, and then you go ahead and plug this motissier hat onto it, and you have basically all the devices that you would need for chart plotting and also AIS reception. So the other great thing about this is Raspberry Pi, right, is going to cost you about $35, right? So not free, but really, really cheap. Now, for a lot of people, you'll also need to get a micro SD card, and you'll also want to go get a USB plug for it, and maybe a case and things like that. So you can add more onto it and can cost a little bit more money, but it's pretty cheap. And then what we can go ahead and do is we can get a motissier hat, right? And then this is going to cost you about $100. So between the two, you can go get a chart plotter that's doing AIS stuff for less than $150, right? Pretty easily. And then if you want to go add more things to it, that's optional. We'll talk about that a little bit more later on, and we'll get into more detail in some of the follow-up videos. So a couple things that I talked about with Rebecca that are useful to know. So the first thing is where do you get a Raspberry Pi, right? So one of the first places you can go look at is just Amazon. So if you just go search for Raspberry Pi, you can go ahead and find that in a whole bunch of different places, right? So you can see that we come back with a whole bunch of these. A lot of these are sort of set up as kits and stuff. So they have the power plug and maybe a case and things like that. So you can see these being a little bit more expensive than the $35 ones. But you can also just go to raspberrypi.org. Let me go clear this out. So again, I mentioned I was recorded a version of this before, and then had a student interrupt me, which is valid. They're paying money to have my time, so I got to kind of pause when they sort of ask me to help them out. So this is the new Raspberry Pi version 4. It basically looks identical to a Raspberry Pi version 3. And you can see that this is starting at $35. The new ones have more power, so this is gonna be a little bit faster, and this one can get up to 4 gigs of RAM. So as an aside, if you wanted a really nice little media center computer for your boat, you can go install this and then use that, plug it onto your, you get a TV on the boat, you play your videos on there, maybe little video games and stuff. Nothing really graphically, intensive, but it'll play movies and stuff like that really nicely. So that's really, really nice. So this is the Raspberry Pi, and one of the things you can go do is if you go to buy, there's a section here somewhere. If you go to products, probably is the best way to do it. And Raspberry Pi Model 3 is the main one that we'd want to go ahead and use with this. So if we go down here, Raspberry Pi 3 Model B, here we go. So this is sort of the full version. If I go click on this, it's going to take me to a page where hopefully, if it loads, it'll give me information. Try to reload that. All right, there we go. They just updated their products. They have a new version today, so I'm guessing that they might have a little bit more traffic to their website, so it might be a little bit slow, something like that. So the idea here is you can see here that we've got this little device. It's really neat, very, very small. And if we go look at where to go buy this, so what you can do is scroll all the way down to the bottom and get this little buy now thing. And you can go pick your country. And you can see that this is pretty much available across the world. So if Amazon doesn't make sense in your environment and you're in Estonia, just select Estonia and it will show you a website that you can go buy it from, right? So that's the idea. Also, they guarantee that they're going to continue making these until 2023, right? So basically for each model that they come out with, because a lot of times this is used in industrial use, they'll sort of say how long the lifetime is going to be for this device. So that's really nice. Additionally, the form factor has been very consistent over the years. So you can actually go use a Model 2 with OpenPlotter, and it basically will work. It's the exact same layout as the Model 3. It just has a slower processor, right? So the Raspberry 4 actually is the first one that's changed the layout, and it's very, very small changes, just the power and the video out. So the Raspberry Pi 3 has a full-size HDMI. The new ones have a mini, and then they have micro USB power as opposed to USB-C. But this is basically the board. So you can get them from Amazon. You can get them from somewhere in local for your country. So if you're cruising around the world and you're maybe if you're out in French Polynesia, it might be difficult. But if you're most places, you can get these. So this is really, really nice. So one of the things that you'll see is that it's got a getting started guide over here. And this is sort of more or less what I'm going to talk about when I go through setting this up and installing it. So it's going to talk about how to go get this configured, how to go plug it in. And then you can go through the process of, the different models that they have, the power supply requirements for it, how to go install the SD card. It's very friendly because this is made for students. So the documentation around this is really, 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 really good. So you can go ahead and get a bunch of adapters for depending what we want to go do with this. We then need to install the operating system. So here they're having us download Raspberry Pi or Raspbian, which is their operating system or something like that. Instead, what we would do is we would go to openplotter.org, which is this site. It's also sailoog.com. I guess that's the people behind the project. But if you go to openplotter.org, it'll take you there, and you can download the version of their distribution, which basically is already set up for you from there, right? So I know this is a lot, but it's really very, very useful. So once you get that installed, you can now start using this as a chart plotter. And the easiest way, I think, is to go ahead and get this motissier hat adapter. And you can see here that basically what it does is it just plugs on top like a Lego. It's one of the really neat things about a Raspberry Pi is it's designed so you can add stuff on top of it that extend the functionality. And this has your GPS, it has your AIS receiver, it has a barometer, it has all that kind of stuff just built right onto it and just clicks right on there. And then all of a sudden, turn it on and you've got all that stuff ready to go. So if for some reason you have to go install this in a part of your boat that has a lot of metal or magnets around it, that might interfere with the GPS. So they have an external plug for your GPS that you can go ahead and connect to. And they also have this little adapter that you can go connect to a VHF antenna, right? So by connecting that to a VHF antenna, you can get your AIS targets integrated into, OpenCPN, right? Which is great. So it also gives you, because it's got the humpus and it's got the gyroscope, it's going to give you heel, trim, all that kind of stuff for your boat, and works, just generally really nicely. So you basically get an OpenPlotter installed, and then you can go ahead and get this functionality, right? So that's really, really, really neat. And I'll sort of jump over here to the OpenPlotter section. Close this out. Nope. Go back over here, and we'll look at all the different stuff that it has available as part of OpenPlotter. So if I go click on OpenPlotter again, so these are the different pieces that are installed with it, right? So we've got OpenCPN already set up and sort of pre-configured. So that's really, really easy. It's got zygrib, which basically allows you to go ahead and pull down grib files. It's got SDR-AIS support, which is the ability to go get that AIS information from that antenna. And then it also has support for adding NMEA. So, and yeah, I always think it's NEMA, but it's NMA, I guess, addition. And NEMA 0183, you're probably familiar with. This is the old serial connections that we used to use back in the day. And they're great. And if you have a boat like the one that I have, it has a bunch of older equipment on it. So I've got a really nice Furuno radar, but it's using NMEA 0183. So what happened is that most people have moved over to NEMA 2000, right? And this is probably something I'll get into in more detail in another video. But the problem with NEMA 2000 is it's a proprietary protocol. So that means that people can't just use this on its own. So one of the things that this means is that it allows marine electronics companies to artificially inflate the prices of their hardware because other folks can't interact with it unless they pay a license to go use NEMA 2000. Additionally, if they do use NEMA 2000, they're not allowed to give any information to other people. So it makes it very difficult for new vendors to get into the market and disrupt things. It makes it very difficult for you to have compatibility between devices sometimes. So a lot of times you'll see people that use exclusively a BNG system or exclusively a Raymarine system, even though they're NEMA 2000 and they technically should all be able to talk to each other. Sometimes they kind of don't. So that's where Signal K comes in. Signal K is a new protocol, relatively. It's about 5 years old, that allows you to go use standard internet protocol, IP, just like you would use to connect to any PC on the internet, any server on the internet, and like you have on your local LAN or wireless. And what this does is it basically sets up an address where everything can go send it to the Signal K server, and then it can rebroadcast that to all the other devices. So what you can do is you can get adapters for NEMA 0183 and adapters for NEMA 2000. And once they're on Signal K, you can access that information from everywhere. This is getting a little bit more into the advanced stuff, but this allows you to go extend the functionality of this. So the example that I gave Rebecca and Patrick is if you wanted to, you could go get a little microcontroller. And a lot of people are out there who know how to do this now because microcontrollers also have gotten much easier in the last few years. And you could go get a little open circuit on there. And you could have two little wires, right? Just really, really simple. And you could put them in the bilge, right? And if there was water in between those two wires, that would create a circuit. And then it could go send off an alarm. And a lot of people say, well, I've got a bilge alarm. Why would I care about that? Well, this is connected to the internet. And this is a real computer. So if I have something like a hotspot and you have that on your boat, so your boat is connected or you have Wi-Fi at your boat, maybe you're at a marina, what you could do is you could actually have this, email you or send an alert to your phone or potentially call you or something to alert you that there all of a sudden is water in the bilge above this high water mark. That might be really, really useful. So it's an interesting idea. The other piece of this is that it has the ability to integrate with autopilot, right? So this is the part that I want to pause on. This is a really, really, really interesting idea. It runs something called PiPilot, and it allows you to basically replace a very expensive autopilot controller with PiPilot. PiPilot is pretty well tested, it seems like, with small boat autopilot. So your Raymarine tiller pilot kind of thing, right? So those. This seems to work very, very well with those. There's some testing with other ones. This is one where your mileage may vary, right? RTL-SDR, very, very well understood. Raspberry Pi, very, very well understood. OpenCPN, very well understood. This is newer, right? So when it comes to the autopilot stuff, if you are technical, if you're already familiar with this stuff, if you want to play around with this, this is potentially really interesting. If you're somewhere that you cannot get an autopilot, you're way out in the boonies, and you want to hook this up to your system and try to get that working, that could be a lifesaver. But I think for most people, if you already have an autopilot controller, if you have a system that's doing that's potentially a good thing to look at. Now, personally, on my boat, this is something I'm looking at because I've been having problems with, my autopilot computer. So that's something that I'm considering looking at, and I'll probably delve into. But I also used to work at Microsoft, and I was giving a lecture at Google 2 weeks ago. So that's part of my, personality. I tinker with things. I'm comfortable reading and writing code. So it might not be for everybody. And there's a bunch of other stuff that you can go ahead and do. But there's a couple other things that are really, really useful and important about this, which is with your Raspberry Pi, it has a Wi-Fi adapter on there. So you can actually set it up as a Wi-Fi access point, or if you have a network on your boat already, you can join it to that Wi-Fi access point. And at that point, you can go connect to it remotely. And you can do this a couple different ways. You can do this through, an iPad, you can do this through a phone, and you can get right to the desktop. But additionally, if you're using something like Signal K, and a lot of the stuff will already be exposed by Signal K, so your heading, your speed, all that kind of stuff, that it can go calculate with GPS and magnetic, all that kind of stuff, compass, all that. So all that'll be exposed via Signal K. So you can either go to it in a web browser, and you can go ahead and see all this kind of stuff really nicely. And in fact, I think if I do a quick search for Signal K, this is going to show us, I think they have a demo here that we can go ahead and use. Yeah, so if I go click on demo, this is going to go ahead and show us an example system. So this is basically not real information, obviously, but it's just sort of an example that you can go see. So this is the kind of web site that would actually be running on your local Raspberry Pi on your boat, right? So basically have a version of this. So this is giving you information about Signal K itself, and it's also saying, the stuff that we're getting, right? So we can then go look at the web apps, and then we have a whole bunch of different stuff on here. So here I'm going to go ahead and look at the first one. So this is going to go ahead and show an example of a device. So that obviously this isn't real data, but this is showing us your thing. We can go ahead and sort of zoom in. We can go ahead and see all this kind of stuff. This is all running over a web browser. So that means that you can go access this from any device. You can access this from your iPad. You can access this from another computer. You can access this from your phone, and it will be set up more or less accordingly for that. So this is one of the sort of predefined ones that are installed, just kind of ready to go, right? So if we then go ahead and look at another example one, go back to our web apps. Let's say sail gauge, right? So this is another really useful one. So this is just kind of showing us, our heading, and kind of what's going on with where we're going, and basic stuff like that, right? So pretty simple. If I go back over here to simple gauges, this is going to be exactly what it shows like. So I'm really, really zoomed in here. If I kind of zoom out a little bit, you can see that we get some gauges here. So you can go ahead and have that on, again, iPad or any kind of screen that you wanted, and you can go ahead and adjust these. You can also go add new sources. You can go look at a log of the stuff. I guess this is, it's not real data, so it's not really showing us that. But you can go ahead and look at speed over ground. If you have things like depth sensors attached to it, you can go see those. See your heading. So if you think about the cost of, buying multi-purpose gauges or sort of replacing those, this can do that too. So here's another instrument panel, and again, all of this stuff is, basically free. So this is another example. So this one has a bunch of different stuff on it, and then the nice thing about this one is that you can go ahead and unlock it, and then you can go change the settings so for what you want to go add to this, right? So you can go add more widgets and stuff if you want to go ahead and do those. There's other things that we can go add depending on what information is being sent to the OpenCPN server. So again, if we just go back and look at it, we can go see our heading. You can go see our speed through the water. You can see the course over ground, speed over ground. This is probably one of these is the one with magnetic variant. No, because this is true, and this is the magnetic. You can look at your wind speed, all that kind of stuff, right? So again, this is, not perfect, but it's pretty nice. I mean, this might just be kind of looking weird because I'm weirdly zoomed in. But if I zoomed out a little bit more, if I was looking at another kind of device, that might render a little bit better. I'm also using Edge here because I can annotate it. So that's pretty cool. This is another one that we can go ahead and look at. So this one has AIS targets on it. If I don't know if they'll actually show it to us, but kind of zoom in over here. Let's see. So this is where our boat's supposed to be. All right, so I don't know if that'll sort of really give us a good sort of example for that kind of stuff, but but yeah, so you could go ahead and look at AIS target. So the idea is it's really, really nice, or you could also go ahead and just connect to the desktop and have OpenCPN running, but have that in your iPad or your laptop. And the great thing is if you're on your laptop, it might be using a decent amount of power, so you can go check this. You could close it down when you want to get more information, and then otherwise you could just be looking at your iPad or your phone to go check this stuff. Also, because it's on IP, if you choose to, you can go set this up so it's all visible remotely. So, you can go look at all your gauges, and, you could have things like, sensors and stuff. And then if I go to something like, let's see, I use Android. So if I go look at Signal K, Android, there's a bunch of different apps you can go ahead and use. So if I go look for Signal K Android, you can go see that there's going to be a bunch of different applications that you can go ahead and use to go look at this kind of stuff that you can go look at. So this is Sailboat APK. I haven't really used very many of these. And I know that there's some really nice ones for iOS. So if you've got an iPad, there's let's see, iOS. Whoops, what just happened there? iOS Signal K. So, let's see. I think this actually might be a way to do it. So this is okay. So this is a list of different sort of devices. We can get Fairwind. We can get a bunch of different sort of devices, and it looks like things that we can go ahead and use to view this. So Signal View, it sounds like is an example one. So let's go. Not sure why that's not opening up. So let's see. Oh well, I'm not going to go spend a whole bunch of time boring you to death while I go look things up. But there's a bunch of apps that you can go use on your phone or your tablet to go ahead and view this. It'll be really nice and sort of set up. And basically, they just need to be on the same Wi-Fi network to go view all that stuff. So that's more or less sort of a general kind of introduction to OpenCPN via OpenPlotter and all the kind of different stuff that they have available for you. And it's a pretty cheap way to go implement this. So it's something I think that a lot of you guys could look into as either a way to kind of get started or a way to go ahead and use as a backup. So I'll try to go follow this video up with an example of doing an install and then maybe a quick overview of using OpenPlotter on the desktop and kind of get that to get started. So hope that was helpful. Again, don't recommend that you rip out and replace all your stuff, and only do things that you feel comfortable with on your boat. So yeah, take care.